right? So joining of two relations using a natural join. So natural join, it joins two tables based on the same attribute name and data types, right? So it joins only two relations based on the same name, attribute name, and the data types. So the resulting table will contain all the attributes of both the table, but keep only one copy of each common column, right? So for example, you have two tables or two relations, student relation and marks relation. Now we are going to perform a natural join on this two tables, right? So the resulting table will contain all the attributes of both the tables, right? So it will contain the attributes of both the tables, student and marks, but keep only one common copy, keep only one copy of each common column, right? So here the common column is going to be roll number. So we are going to perform natural inner join of the table student and mark respectively. It will keep only one copy of the common column. So we'll have 2B70, right? So the roll number, name, marks value will be 2B70, 3C50, right? Right. So it will have only one copy of the common column, right? So whereas inner join, right? So inner join, it takes two table. It takes it's a binary operator. Again, it uses two tables on the basis of the, and it joins the two tables basis on the column which is explicitly specified on the on class. So the resulting table will contain all the attributes of both the tables, including the common column also, right? So here it does not eliminate the common column. It contains all the attributes from both the tables, including the common column also. Again, here we are going to explicitly specify the columns that are joined by based on the on clause, right? So here the query is going to be select star from student S, inner join marks M on S dot roll number is equal to marks dot roll number, right? So this is the output of inner join. So this is the difference between natural join and inner join. So in natural join, the resulting table will contain all the attributes of both the tables, but it keeps only one copy of each of the common column. Whereas in inner join, the resulting table will contain all the attributes of both the tables, including the duplicate columns also, right? So again, you need to explicitly specify the attributes that are being joined using the on class. Right? So inner join joins two tables on the basis of the columns which is explicitly specified on the using the on clause, right? So this is about working with inner join, right? Right. So we have an example for a natural join. You have two relations R and S respectively. So we are going to perform natural join on the two relations R and S, right? So it is used to join tables based on attribute name and data types, right? So we are going to join these tables by means of A, B, D, right? So B and D is going to be common in both the relations. So it will return right alpha 1, alpha A, alpha, right? So it will return the values that are common in that matches in B and D in both the participating relations. right? So we have only alpha 1, alpha a, alpha. Similarly, alpha 1, alpha 1, alpha a, gamma, alpha 1, gamma, right? So now we'll be using the fourth tuple, alpha 1, gamma, alpha a, alpha 1, gamma, a, gamma, and delta 2 delta 2 beta b. We have the value of b and d is going to be 2b respectively, right? So it's going to be gamma, right? So this is how we work with natural join. So again, we will be able to operate, use some aggregate operators like sum, max, min, average on a particular attribute in a relation. So relational algebra also supports using statistical operations on a particular relation, right? So this is about the relational algebra, which serves as a basics for a relational model, right? So the relational model, storing information in a table-like format, right? So representing data using a table-like format, and again representing the relationship by using table-like format is a relational model, and it is based on relational algebra.